All right, so we're going to do a static display today on this one. So, by no stretch of the imagination am I an engineer or a computer scientist or somebody who knows how to code or anything like that. I mean, I'm a biologist by trade, but I really got into 3D printing not very early on, but kind of a little late in the game. It was always kind of like prohibitively expensive for me to get into it, and I've always heard people talking about how it's kind of just a fad, and it's going to come and go, and so I don't know. I saw it and I started getting into it, and there's this thing at UT called Innovation Station, which is if any of you work for UT or you're a student there, you can get 3 hours of free print time on their 2 3D printers out there. So you don't even have to own one. Just go out there, upload your file, and they'll print it off. And it's even got a little robotic arm that shoots your 3D print into a little bucket, and you can grab it. So I said, all right, so that's not, there's no capital investment there. I'll just try it out, and I'll learn how to do some stuff. And I don't know, I did some stupid things like, I don't know, clip or I don't know, just simple things. Oh, in fact, you know what? I brought up a whole bunch of shit that I 3D printed. So I'll tell you about these in a little bit, and we'll pass them around, so don't jack them, all right? Well, actually, it's okay, because I'll just 3D print another one. So anyways, I started 3D printing stuff, and then I realized there's a ton of stuff in this world that's made completely of plastic that people charge way too much money for. Like, I work in a laboratory, and this stupid piece of plastic is a gel electrophoresis comb, right, that you put inside an auger before you do a DNA gel. Probably 25, 30 bucks on the outside. This is a 5-minute 3D print job right here. There you go. Here, you know what? Here, pick something. Pick something, please. All right. There you go. Okay, so this one's sweet. So check this out. This one is this is an air clamp. So, like if you have water or if you have air, like going into a hose, you know how you can buy those regulators that like cut the water off or make it more or less? Those are at least $5 at, the hardware store. But you could 3D print this, and well, if you want less air or less water, you just cinch it off right there. How cool is that, right? 25-minute print job, 33 grams. Print ABS or PLA is about $25 a kilo, so it's 2.2 pounds for 25 bucks. You can't beat it, right? Anyways, here, I'm just gonna redo this. So here's the other thing. Like, I started drawing stuff that was super expensive, and then I could realize that there's so much stuff out there, I don't even have to draw things anymore. I just go on to Google or that other website that you can go to and download, like type in whatever you want. Like, medical brace for your wrist, for when you need a splint. You just print it, and it prints flat. You put it in hot water, and you mold it to your arm, right? And then it'll be a brace for you. Carabiner, kind of. Thing to hold your beer. Drinking vodka. So you snap it onto the neck, and then you can set it on things. I don't know. Air clamp again. This one was cool because I needed it right away. 11mm wrench, right? Golly, if there's any hate in my heart, it will be for a lack of a tool that I know that I have in my house somewhere. But I really needed it, and I needed it right away. So I put a really low infill, which means that the 3D printer I should have explained how 3D printers work. Fuse deposition molding is when all right, so you see this guy right here? So this dude, he just squirts out plastic layer by layer by layer by layer, right? And it's hot, and then it cools down. Before you know it, there's your print. So I needed this right away. So infill is like, okay, the inside of this doesn't have to be solid, right? So you can make it 50%, 95%, whatever. I did a 40% infill. This was an 11-minute print job for an 11mm wrench. I can't run to the hardware store and grab one and bring it back in that amount of time. And definitely for this amount of money, it's like less than 25 cents, right? Okay, I'm not gonna be able to torque down on my 11mm nut like that, but I didn't need to. It was harder than finger tight, and it got the job done really quickly. Orange peeler. But I didn't know that this little notch was to actually start the peel on the orange, so I took a Dremel on the first model, and I Dremeled it off. And then Callie was like, hey, you needed that. It's okay, I'll just 3D print another one. And then finally, kind of, parts for a 3D printer. Right? You 3D print a 3D printer with a 3D printer. Like, how epic is that, right? Yeah. I bought a 3-pound bag of gummy bears from Fry's Electronics, and they were starting to get kind of yucky because I got hyper-focused on this, and I was doing it till 2 a.m. every night for like a month. I kid you not, that really happened. So I got printed a chip clip to keep the gummy bears fresh, right? Another piece for the 3D printer. And then pie, right? Because I like pie. And it's a necklace, so jewelry, right? So I did this, right? Guess how much this costs?
$1,000.
$1,000, right? So your traditional run-of-the-mill ready-made 3D printer is about $1,700 right now for a Cartesian, right? This is a Delta, which is kind of different. So let me explain this. So Cartesian, right, is like XY coordinates. So the printer, when it squirts the hot plastic out, can only print like this and like this, right? And it also has a heated bed to keep the print like kind of stationary. And sometimes they'll move the heated bed this way and that way also, which is cool, except for like, you can't really print a circle because you can only go this way and that way, right? And so then somebody said, all right, so there's this thing we could do at Delta. The way Deltas work are, there are these pulleys that you just like pull on, and it just can do this thing. So the beauty of that is, well, now we can print in a circle, and, well, if we want to make it taller, all we need to do is just make taller rails and add more pulley track, right? So I could have a 3D printer that can print 8 feet tall for almost the same amount of money that I have to print this, right? The downsides of Deltas is that those arms don't allow for very long prints, where Cartesians can do longer prints, XY, right? Deltas can do better Z. And then there's this thing called polar. I don't know how that works. But it's like north-south, so I kid you not, the bed and the nozzle they rotate on each other, and it prints like, no. Especially if you're gonna build one, right? So anyways, $1,700, yeah right, not gonna do that, right? $345. Folger Tech. And that's, so the printer itself is $289, but I bought 25 kilos, or $25 worth of filament, and I bought this, which is an LCD. I don't have it hooked up, right? An LCD monitor that says hacker, hacker show and tell show, something, whatever. And then that allows me to manipulate the print mid-print, right? So I use this little device here, and I can change the speed or the temperature, or the cool thing about it is that it's got an SD card reader on it, so I don't have to dedicate a computer to the print. I can load the print onto the SD card, slam the SD card into the LCD, and then just have it printing on its own, happily, right? Hopefully. So now let's talk about some of my frustrations with 3D printing. Calibration. Calibration is key. This bed level probe, right, or this bed level, and being off by 0.2 millimeters will make a substantial difference in your print. Because, okay, so if this nozzle thinks that, the nozzle thinks that this is the ground, but your printer is actually like this, or let's say it's like this because you didn't know what you were doing, the nozzle drug itself into the aluminum bed the first 10 times you were doing it, right? It's gonna be difficult. So they added a little servo that just drops down and then probes the bed surface. And it teaches itself what the bed looks like. If it's up, if it's down, or whatever. Really awesome. And then it could be, I could, bolt this thing to the wall sideways and it would still print nicely to the bed surface. Calibration, temperature, and extrusion rate. So there are these things called stepper drivers or stepper motors, which are what the motors turn on, right? You have to make sure that you're getting the right amount of electricity into it. If you're getting half the electricity, well, you're going to get half the size of your print. It's going to be 50%. I did that for like 2 weeks. I was just making everything 200% the size, and then it was working out for me, right? It's not the right answer. Yeah. So there's that, and then extrusion rate. If you try to squeeze all that plastic through that little, tip, it's going to clog it, or it's not going to go all the way. So you got to get the right extrusion rate. It's not for the faint of heart. I had to learn how to solder. Yes, I had to learn how to solder. But guess what, guys? It's not that hard. Soldering, people are like, oh, soldering, no. No, it's actually stupid easy. You just turn the thing on and it gets hot, and you touch it to the piece of metal that you're looking for, and then you run this other piece of metal and don't look at it too closely, and it'll melt, and then you make sure that you get a nice solder, a nice heavy solder on there, and you're good to go. And then software, right? Yeah, I had to learn Arduino. It's not too terribly easy, but they make it really easy for you. You just download the open source software, and there's this thing called calibration.cpp, which is the only place you'll need to go. Trust me, don't mess with the other stuff. It's not a good idea. So calibration tells it, hey, how tall is it, right? How tall is the printer? So mine happens to be 429 millimeters. How big is the bed diameter? So you just input all these things, 152, 425 or whatever. The rate at which you would want to extrude, your millimeters of extrusion, all of these things, all that happens in calibration.cpp, and they have a build kit. In the build kit, right? Honestly, building it was the easy part. The calibration was the difficult part. In the software portion of it, I was able to walk myself through a lot of it. But auto leveling, I had to get into the forums. Yeah, but I did it. I still have it. I was able to print things that have made my life better. And so I think you could do it, especially if it's only $345. Come on, right? It's way better than $1,700, and you don't have to use the stupid proprietary filaments, or any of that dumb stuff. This is called a rep wrap. In fact, this one's called a Coastal 2020. I got it on FolgerTech.com, and it was one of the best purchases I ever made. I think that's 10 minutes. Oh, hold on. So this thing right here holds a 1.5 millimeter, 1.5 milliliter cuvette, which is, you don't think that that's This on the outside is like $80 or $100. Anything that says laboratory on it is just like automatically stupid expensive. So here, I'm gonna pass this around, and then I think that that's my talk. Right? Am I good, or do you keep going?
You're good.
All right.
Thank you.
That's how a 3D printer works. What are your questions? Go ahead.
I guess I'm confused, like, as far as the picture that you're giving the printer to tell it what to print, like, how does it know what the dimensions are? Like, if I'm just going to Google Images, like, does that make sense?
That's an excellent question. So you have to send the printer a 3-dimensional image.
Okay.
You can't send it a 2D image, or else you only get a one thing. But here's the deal. All right, there's this place called Thingiverse, and there's a whole bunch of other places called not Thingiverse that are probably better than Thingiverse. They're not as large. But you don't even have to know how to do 3D rendering. All you have to do is say, hey, I want an 11mm wrench. And there's at least 50 people that have already made an 11mm wrench. You just download the STL file, send it to your printer, and then boom, start it up. You're good to go. Not that 3D rendering isn't awesome. You should definitely get into that as well. There's this open source called Blender. It's great. All right, go ahead. Callie.
What kind of materials other than plastic can you use?
Yeah. So in this one, you can use ABS, something butylstyrene, right, which kind of stinky and it's higher temperature, but it gives you a cleaner print and it dissolves in acetone, so it's easier to clean up. Or you have PLA, which is polylactic acid. It's it's kind of like the organic-based version of it, which smells sweet and doesn't produce a toxic fume when you print. So I use PLA. It's not as smooth of a print job, and it's at a little bit of a lower temperature, but it does the job just fine. The other ones, we're getting into printing with wood. I know that sounds crazy, but it's actually a hybrid of wood and plastic, right? But for all intents and purposes, it's like basically just sawdust, and that gives the texture of wood and the smell of whatever wood it's like. And then I got a buddy of mine who lives in Georgia who owns he's working with a startup that's doing biomass, like switchgrass, or actually aquatic biomass, duckweed, microalgae, all sorts of different kinds of aquatic biomass, co-extrusions with plastic. And the beautiful thing about this is that when you increase or decrease the relative ratio of plastic to biomass, you can increase or decrease the biodegradability time frame. So let's say that we want to print something that's only going to stick around for a month. Maybe one of those pots that you stick in the ground when you plant a plant, and you just put the pot in the ground, you want it to break out, Well, you can just use a 70-30 hybrid of biomass and plastic, and then there you go. Some of the higher ones can print metal. There's this website called Shapeways, where if you don't have a 3D printer but you want something that's 3D printed, or you see something on the internet and you're like, oh man, I really like that, I'd really like to buy that. You go to Shapeways, upload the STL file, or there's a whole bunch of people that have stores, and you can print it right from there. They get a little cut, and you can print it in basically anything you want. They have one that prints in gold, so, for all you ballers out there. Go ahead.
Yeah, I've seen most recently somebody printing in clay and firing it afterwards. Also seen people printing in chocolate.
Yeah.
And
Chocolate.
And cheese whiz.
There's this really other innovative way of, it's called bioprinting, right? Where we're printing cells, not with like heat or anything like that. Go ahead.
Yeah, they're 3D printing organs. They're actually working on the first human heart. Recently, I saw a TED Talk where they had this kid where they 3D printed artificial kidneys. But at the time that he got up on the stage to basically talk about how good his kidneys were still working, it didn't like
Wow.
still fully functional.
That's incredible.
3D printed 10 years prior.
Yeah.
Artificial organs.
Yeah, it's amazing to think, you know what? In 20 years, remember this day and be like, wow, that clown was up there talking about 3D printing plastic. I mean, we're going to be able to do so much more with this technology. Please go ahead.
I just wanted to say that what you were saying about people saying 3D printing was just a fad.
Yeah.
That's exactly what my grandfather said about personal computers.
Yeah, right. So, especially like if it was prohibitively expensive, I would gig it. But yeah, $345, and I'm over here making wrenches. Come on now. Yes, over here in the back.
Yeah, coming board just robots just side of the
Are we talking like?
Because you're already printing parts to build new more
No comment.
3D printers. They're able to make more of themselves.
Self-replicating.
Yeah.
Thanks, you've been a great audience.